Hey everyone, welcome back. I am absolutely thrilled to have you joining me for this explainer, which is going to serve as your dedicated lecture on a really foundational topic in software engineering. Today, we're focusing squarely on section 2.4 of your textbook, which is all about process improvement. And then we're going to wrap up with a comprehensive summary of chapter 2. As future software engineers, it's not just about knowing how to write a bunch of code. You really have to know how to look critically at the way you and your teams actually build that software, and more importantly, how to do it better. So let's dive right in.
Okay, here's our roadmap for today's session. Feel free to structure your notes around this. 1. Introduction to process improvement. 2. 2 approaches to improvement. 3. Process improvement cycle. 4. The capability maturity model. And finally, 5. Our chapter 2 summary.
All right, let's kick things off with section 1, Introduction to Process Improvement. I want to hook you right away with a really fundamental question. One that literally every software engineering firm out there faces on a daily basis. Why do companies actually care about process improvement? I mean, why not just sit down, open your laptop, write the code, and be done with it? Well, the reality is that the real world just doesn't allow for that kind of laid-back approach. The truth is, there's this relentless demand from the industry for cheaper software, but at the exact same time, clients are demanding better software quality. And to top it all off, it all has to be delivered on these ever-tighter deadlines. It's wild. These three relentless pressures basically force companies to look inwardly. They can't just tell their developers to work harder. They have to figure out how to work smarter. They have to find ways to enhance the quality of their software, reduce their costs, and accelerate their development processes all at once. So, following our golden rule of define first, explain second, here is the exact definition you need for your exam notes. Process improvement means understanding existing processes and changing these processes to increase product quality and/or reduce costs and development time. So just for a quick mini recap before we move forward, the industry demands faster, cheaper, and better software, right? Well, process improvement is the systematic mechanism we use to actually pull off those seemingly contradictory goals by evaluating and tweaking exactly how we do our work. Moving right along to section 2, 2 approaches to improvement. As you might guess, there's definitely more than one way to tackle process improvement out in the industry, and they actually represent two very different philosophies. You absolutely need to understand both of these competing approaches. On one side of the ring, we have the process maturity approach. This is deeply rooted in plan-driven development. It focuses heavily on improving process and project management, introducing established good practices, and striving for a really high level of predictability. But the downside, it usually requires increased overhead. We're talking a lot more documentation and formal activities that aren't, directly writing code. Now, on the other side, we have the agile approach. This one focuses entirely on iterative development and deliberately reducing those exact overheads. The primary goals here are rapid delivery of functionality and being super responsive to changing customer requirements. Agile champions flexibility and speed, intentionally minimizing all that formality. Honestly, people who love one approach are generally quite skeptical of the other. But as an engineer, you've got to be objective and understand both tools in your toolkit. To recap real quick, process maturity is all about strict predictability and management, while agile is all about speed, flexibility, and minimal overhead.
All right, section 3, process improvement cycle.
Take a look at this foundational diagram here, which comes straight from your textbook. This shows the overarching cyclical nature of process improvement, specifically within that maturity approach we just talked about. Notice how it's a loop? It is definitely not a one-time quick fix kind of thing. It's a continuous, ongoing journey. Let's walk through these 3 steps nice and slowly so we really get it. Step 1 is measure. Because honestly, you cannot improve what you do not measure. You must measure one or more attributes of your software process or product to form a concrete baseline. Step 2 is to analyze. You take those measurements you just grabbed and assess your current process. You're looking for weaknesses. You're looking for bottlenecks. You might even draw up highly detailed process maps here. You analyze characteristics like exactly how fast or robust the process really is. And step 3 is change. Based on what you just analyzed, you propose and introduce changes to fix those specific weaknesses. And then what? Well, you loop right back to step 1. You remeasure to see if your changes actually did any good. Remember, this is a long-term, continuous activity. As the business environment shifts, your processes are going to constantly need to adapt. So, recapping the cycle. Measure to get a baseline, analyze to find the actual problems, change to fix them, and repeat the whole shebang. Let's jump into section 4, Capability Maturity Model. This brings us to what is arguably the most critical, most exam-heavy portion of today's lecture. But before we just memorize the levels, let's understand the historical context, the why behind it. The CMM was proposed back in the late 1980s by the Software Engineering Institute, or SEI. Why did they make it? Well, the U.S. Department of Defense needed a concrete way to assess the capability of their software contractors. They obviously only wanted to hand out massive multi-million-dollar defense contracts to companies that actually had a proven mature process. This military origin is exactly why the CMM is so incredibly structured and formal today. So let's meticulously walk through the progression of these 5 levels. You really need to know these intimately. Level 1 is initial. At this baseline level, goals are met and the scope of work is explicitly set out and communicated to the team. But it's pretty basic. It's often very ad hoc and chaotic. Level 2 is managed. Moving up, organizational policies are now in place. You've got documented project plans and resource management and process monitoring procedures exist. The specific project is managed, sure, but perhaps not the whole company uniformly. Level 3 is defined. This is a massive step up. This level focuses on organizational standardization. Every single project adapts a defined, standard set of organizational processes. Process assets and measurements are now being collected uniformly across the board. Level 4 is quantitatively managed. Now we're introducing some intense math. There is a strict organizational responsibility to use statistical and quantitative methods to intimately control all subprocesses. Level 5, the absolute peak, is optimizing. The organization uses all those statistical measurements to drive continuous process improvement. Trends are constantly analyzed and the processes are proactively adapted to changing business needs.
Now, I want to preempt a very common student misconception here. You might be sitting there thinking, am I actually going to use this when I graduate and join a tiny tech startup? Well, probably not. Due to the incredibly high overhead of formal process improvement and all that documentation, this strict 5-level maturity model is mostly used only by large software companies today. It's just very difficult and frankly overkill to estimate maturity with the agile processes that are so often used by smaller teams. So to briefly recap CMM, it is a 5-level framework going from initial all the way to optimizing. It was originally built for the military, and it's used to standardize and mathematically control software processes, primarily in large corporate environments.
And finally, we've reached Section 5, Chapter 2 summary. Okay, let's consolidate everything you've learned throughout Chapter 2. I want to provide a really robust, structured recap right now to completely solidify this foundational knowledge for your upcoming assessments. First off, we learned about software process models. Those are the abstract representations of exactly how we work. We discussed the traditional linear waterfall model, the much more flexible incremental development, and the clever integration of reusable components. Second, we identified the 4 fundamental activities that are common to literally all software processes. Those are specification, which is where we figure out what to build, development, where we actually build it, validation, where we check if it works correctly, and evolution, which is maintaining and updating it over time. Third, we looked at coping with change, because change is inevitable, right? We discussed using prototyping to avoid making really poor, expensive decisions early on, and structuring our processes for iterative delivery. And finally, today we covered process improvement, the cyclical process of measuring, analyzing, and changing our workflows to ultimately yield better software.
Now, for a bit of targeted exam focus. Please listen closely to this part. You absolutely must be able to list and describe the 5 levels of the capability maturity model, and you have to do it in exact order. Remember that progression: initial, managed, defined, quantitatively managed, and optimizing. Be sure you can explain what happens at each step, particularly regarding organizational standardization and statistical control. Put a big star next to that in your notes. I just want to take a second to congratulate all of you on mastering the fundamentals of software processes. It's no small feat. You now have a really solid framework for understanding how professional software is planned, built, and evaluated. But before we go, I want to leave you with a provocative thought to chew on. If the strict process maturity approach is simply too heavy and bureaucratic for small projects and fast-moving startups, how do modern developers actually survive when customer requirements are changing literally every single week? Well, the answer lies in leaving the heavy documentation behind and embracing something much, much faster. And that, my friends, brings us to the agile approach, which is going to be our next major topic. Thank you so much for joining me for this explainer. Study hard, and I will see you next time.